Alright, let's get this going. We've got angles of polygons today. You will find and use the sum of the measures of the interior angles of a polygon, and you will find and use the sum of the measures of the exterior angles of a polygon. Okay, so how do we start off with this? Well, first off, we need to define what is a diagonal. So let me back this up just a wee bit. Okay, so a diagonal of a polygon is a segment that connects two non-consecutive vertices. So if I go from a point like here on top and I connect it to other corners or other vertices on that polygon, that's a diagonal. Why is that important? Well, by having a diagonal, we can see here that we can divide up other polygons like a quadrilateral, pentagon, a hexagon into smaller triangles. Notice that a triangle does not have a diagonal. Okay, and if we do that, then we've got multiple triangles, and by thinking that allows us to see this thing that says, okay, there's three sides, number of triangles, there's 180 degrees inside that triangle. Since in a quadrilateral, I've got two triangles formed, that's 180 degrees for each one, that means the interior angles add up to 360. And a pentagon, 540, keeps going like that. So what does that mean? It gives us something like this. Yeah, we'll come there. Theorem that says the sum of the measures of an n-sided convex polygon, and I should say the sum of the measures of the interior angles, I may have misput that, some of the measures, so let's make sure we note that this is for interior angles only, is n minus 2 times 180. So the n stands for sides. So like here, I'm going to put in a five-sided figure, a pentagon. So 5 minus 2 is 3, and 3 times 180 would give me 540 degrees. So all these little angles here would add up to 540 degrees. Okay, so where is that important? Okay, so let's find the sum of the interior angles of a convex heptagon. Well, here you would have to know that a heptagon is 7 sides, and then you would say 7 minus 2 is 5, and 5 times 180 gives me 900. Okay, so that you may remember what you need to know here, here is a chart that gives you all the sides up to 12. Okay, I seriously doubt I'm going to go higher than 12. But here you go, there's all the sides. So if you see hexagon, you know it's 6 sides. You see nonagon, you know it's 9 sides. You see hendecagon, you know it's 11 sides. That type of thing. Okie dokie. We continue to move on. All right, let's look at an algebraic way of asking this question. All right, find the measure of each interior angle. Well, okay, so this thing has 4 sides. So I know that if I add up angle A plus angle B plus angle C plus angle D, 4 minus 2 times 180 would give me 360 degrees. So this adds up, the angles add up to 360. Now, the little squares mean those are 90 degrees, so I've got 90 for angle B and 90 for angle C. For angle A, I've got a 3x, and for angle D, I've got an x. And then I can combine my like terms. 3x plus 1x is 4x, 90 plus 90 is 180. Subtract, and then divide. Whoops, I went a little too far. Okay, let's back that up a bit. Subtract 360 by 180, you get 180. Then divide by 4, and you would get 45. So that means x is 45, angle D is 45. That means A is 3 times 45 because it says 3 times x, so that would be 135 degrees. So each one here is, like angle A is 135, angle D is 45, and then B and C are 90 each. And there you go. I've answered find the measure of each interior angle. Fairly simple like that. Now, here's one with exterior angles. Let's see if you see a pattern. I'm going to let this play out and kind of go there. Notice that I'm going to add these up. Oh, he's adding them up. It's really difficult. Notice those add up to 360. Now here's a quadrilateral with some measurements. And then I'm going to add those up. And guess what? They add up to, let's find out. And here we go, 360 degrees. What do you think this next one is going to be at, say, a pentagon? That's 98 degrees, by the way. And when you add these up, guess what? They add up to 360 degrees. Wow! The mind, it is blown. It is like, whoa. Okie dokie. So, what does that tell us? That tells us that on any polygon, exterior angles that the sum is going to add up to 360. So when we add up all the exterior angles, it's going to add up 360. No matter how many sides, it's going to still be 360. What does that mean for this? Okay, let's look at an example. So here's an example, and this tells me, okay, I know 2x minus 5 plus 3x plus 10 plus 6x minus 5 plus 2x plus 5x. All of that adds up to 360 degrees. And then you combine your like terms. You got 18x. The negative 5 plus 10 minus 5 is going to give me 0, so that gives me 18x is equal to 360. So 18x is equal to 360. Divide, you get x is equal to 20. So there I found out that x is equal to 20, and then from that I could even say okay, 20 times 3 times 20 plus 10 is 70. And you could find out all the angle measures by just substituting the x and the 20 into that, and kind of going from there. Anyways, you know what? I think we are good and we are done, and that is it. We will talk about what is a regular figure later on, and kind of go from there. Anyways, that's it for today. Y'all, thank you so much for your time. Y'all take care.